Hey everyone, this is Anul Mahidaria and welcome to this fourth session of Introduction to KiCad and FreeCAD at HackadayU. Alright, so let's begin by launching FreeCAD. I'll be using version 0.18, although I've been using version 0.19 for a long time now. It's been fairly stable. When FreeCAD starts up, we are presented with the start page. Start page gives links to several demo projects that you can walk through. There's also a helpful help section with links to the various workbenches and documentation and so on. But after a while of having used KiCad, you can disable this under preferences. Let's close that and start a new document by File New or clicking on the icon. And these are the three main sections of FreeCAD. The main canvas. At the top is the toolbar and the menus, and on the left is what's known as the combo view. Within the canvas view, we have the navigation cube, which can be enabled or disabled via preferences. And at the bottom right is the XYZ axis crosses. Depending on how you like to set things up, you can choose between different navigation inputs. So my default is gesture, but you can also use touchpad or CAD, for example. FreeCAD can open multiple files, so they get tabbed here at the bottom. And the first thing we ought to do is go to Edit Preferences and set up a couple of things over here. The important one is under General Units. Make sure you decide and select the one that you need to use. By default, it's standard millimeter, but since for this project in KiCad we have used the imperial measurements, I'm going to continue using imperial decimal for this particular project. The other thing you might like to do is set a short enough auto recovery information. The default is 15 minutes, I set it to 5. So we can just click on OK. The other thing you have to do is make sure you have the required add-ons, and that is accessed by Tools Add-on Manager, which then shows you all of the add-ons that are available. As of now, for us, we need the KiCad StepUp Tools, so that's the one that you have to install. So we can close that. You can also go to Tools, Customize, and hide the workbenches that you will not be using. Panels. You can enable or disable certain panels. If there is an error in your document, usually the report view will pop up even if it is unchecked over here. But other than that, just having the combo view is useful. Alright, so with that, let's give a quick rundown of how you can get started with using the basic CAD commands in FreeCAD. It's kind of difficult to give you a deep rundown on this, so I'll just skim through the surface and give you a quick glance of what we can achieve using the common workbenches. The easiest way to get fair understanding is to go to the part workbench, which brings up a list of primitives that you can get. For example, here's the cube, then you can have a cylinder, sphere, a solid cone, and so on. And then you can perform certain actions on items that you select, things like revolving or mirroring, adding a fillet or a chamfer, or you can also carry out Boolean operations like making a union or making a cut and so on. This whole toolbar here, the viewport toolbar, and lets you choose different views of your object. And there are some zoom buttons and different display options. Let's start off by saying how we can use that. Let me add a cube. Once you do that, you get a front view of the cube like so. And using gesture mouse control in FreeCAD, the way it works is scroll allows you to zoom out or zoom in. Clicking and pressing the primary button allows you to rotate an object, and clicking the secondary button and holding it down allows you to move an object. If you want to get back to the isometric view, this icon lets you do that. If you want to fit all to the screen, this icon does that. Now, this is what is known as the flat lines view, which is this option over here. But if you choose shaded, you get something that looks like this. If you choose a wireframe, you get a nice wireframe, so that lets you choose hidden lines like so. So usually between flat lines and wireframe is what you'll be switching. So that's a V2 and a V4. So with that, let's see how we can manipulate this object. It's appeared here in the model tree as cube, and once you click on that, you get its properties over here. That includes the dimensions, length, width and height. But if you expand the placement tab, you'll get the position and the axis along which it is placed and the angle. So you can change these parameters. For example, 45 degrees here will move it along the Z axis and put it back to 0 like so. This moves it in the X direction, this moves it in the Y direction and so on. This will be the Z direction. And you can also give negative values over here. And finally the length, width and height of the box. If we are trying to do something for the KiCad PCB that we made last time, let's try and make a box. The bottom part of the box that might go below the PCB, and that covers this part of the circuit board, and this much stays exposed. So we'll probably be needing to build a box whose insides are 2.175 inches wide by 1.6 inches tall. And then we'll have to give some wall thickness to it. So maybe 0.1 inches on all sides gets me an outside size of 2.375 by 1.8. So let's make sure our box is that size, 2.375 long, 1.8 inches wide, and we don't need it to be so tall, so maybe 0.25 inches tall. And then zoom all. And here's what it looks like. So that's your initial slab on which you're going to do certain operations to make it look like an enclosure. Now, it's not really easy using just the primitives to start drawing your objects. If I needed to hollow this out, I would have to add a second primitive, change its dimensions so that it matches whatever hollow cutout I need to do from here, and then make a cut boolean between these two objects. Let me just place a cube like so and move it by 1 inch in each direction like so. And I have these two cubes now, and I can do a couple of operations, like I can take the first and the second and make a union which makes it one object like so. I undo that, I can choose the first and then choose the second, and I can make a cut of the two that makes a square opening over here. Undo that. And the order in which you choose these elements makes a difference. So instead of choosing the bigger cube first, if we choose the smaller one first and then the bigger one and created a cut, then we get a difference between those two objects. So instead of the cube, we can put a cylinder like so, and if I right click on the cylinder and click transform, I can set increment of 0.1 inch and rotation of 15 degrees. And now I can move this object by dragging these arrows in each of the three directions like so, or I can even rotate it along the axis like so. So green moves it along the Y axis, red moves it along the X axis, and blue moves it around the Z axis. Let's say we place it there, and then we make a difference between the two, and that will give me a circular hole. Let me undo that as well. But you'll notice it really becomes a bit unwieldy to use this procedure to really do anything useful and meaningful. So these primitives are useful only in a very few special occasions. So for this now, let's just delete them. The other slightly better way of doing things is to use the Sketcher workbench, this one, that lets you draw a sketch and then make certain operations on that sketch to turn it into a three-dimensional object. So to give you an example, let me first start off by selecting this icon which says create a new sketch. You have to choose a plane where you need it to be, and for each plane there's also a reverse direction, so a total of 6 directions that you can choose plus an offset. Click OK, and that brings up this two-dimensional drawing window, which you can also, using the Alt key, move like so, but you'd like to keep it visible flat. But there are a couple of sections on the left. You have a section called solver messages, the other one called constraints, and the third called elements. A quick look at the toolbar that has appeared over here. The one you see here allows you to draw several graphical elements like a point, a line, arc, circle, ellipse, B-spline, a polyline, rectangle, polygons, ovals or slots. You can add a fillet, you can cut a line, you can extend a line, and so on. And these are the constraint settings. These let you constrain your objects. For example, 2 points can be made coincident. A point can be made tangential to a curved line or even to a straight line. This adds a vertical constraint to a line. This one adds a horizontal constraint. This one has a parallel constraint. This one is right angle for two right angle lines. This one is a line tangent to an arc or a circle. This is an equality, so two circles of equal radius or arcs of equal radius or lines of equal length. This one is equality constraint, so if you want a line equidistant along the y-axis, you can use this to achieve that. If there are some elements that you want to just lock out without providing constraints or dimensions, you can do that, and FreeCAD will consider it as a fixed constraint. This allows you to add a horizontal dimension to a line. This allows you to add a vertical dimension to either a line or 2 points. Same thing with this, allows you to fix a distance between a point and a line, for example. This sets the radius or the diameter of an arc or a circle. This sets the angle between two lines, and so on. So with that quick walkthrough, let's make a sketch. Here's the rectangle icon. Let me click once, drag, and place it here. So that's our rectangle, and it has 4 degrees of freedom: the width, the height, and the position of one of the vertices with respect to the origin 0, 0. Those are the 4 constraints that we need to fix before this becomes a fully constrained sketch. In order to do that, we want to set the width as, let's say, 2.375 inches, the height as 1.8 inch, and now we want to make it equidistant along the x and y axis. There are 2 ways of doing this. You can select these 2 points and the x axis and give an equality constraint like that, and repeat that in the y axis with these 2 points and the vertical axis, and creating another constraint like that. The other way is to take these 2 opposing vertices and the center one and creating an equality constraint that does the same thing as well. So we have a fully constrained sketch now. We can close this, and we can now apply an extrude operation on this, for which we go back to Part, Workbench, and here is the extrude option. Once you do that, you get another dialog box where you set the height. We wanted it to be 0.25 and say OK. So that extrudes this box in this direction. And this is where things get a little bit better than having used just primitives. I can choose this face, can go to Sketcher again and create a sketch where it asks me how that sketch needs to be attached to this face. Flat face is what you need usually. So click OK, and you get back to Sketcher, and we can now make another rectangle here. But now we know that the wall thickness of this enclosure needs to be 0.1 inch. So this rectangle is going to be 0.1 inch shorter than the outer rectangle on all the 4 sides. Now we can do that using the outer rectangle as references. And that happens using this icon which says create an edge linked to an external geometry. If you click on that, and if I click the left edge and the right edge, that provides me the 4 corner vertices of the bigger cube as references. I can then press escape to get out of that mode. Without giving any dimensions to this rectangle, I can just set these references. The horizontal distance between these 2 points, set it using this as 0.1 inch, and the vertical distance between these 2 points is also 0.1 inch. And I do the same for the other corner, and that's all I need to do. Select the 2 points, horizontal 0.1, and once again select the 2 points, vertical 0.1. And now it is fully constrained with respect to the earlier rectangle, like so. And now I can go back to Part And unfortunately the part workbench doesn't allow you to cut out a hollow over here using this, so you have to do the extrude function again and then do a boolean to cut out the hollow. Let's go to extrude, and I don't want anything along because that's along the vertically upwards direction, but against I want it at 0.15, then click OK. So that's extruded in the other direction. I can hide an element by selecting it and pressing the space bar like so. So that is the bigger rectangle hidden, and that's unhidden, and that's the smaller one hidden and unhidden. Now I can do a boolean between these two. Select extrude, select the other one, make a cut, and I get a hollow like so. Let's view this in wireframe like so, and let's add some fillets to the corner. Let's pick the internal vertical corners like so. I need to use the control key to make multiple selections. So first corner, second corner, third corner, and fourth corner, and use this tool to apply a fillet and give a value. It was 1/6 inch. Click OK. So that's fillet on the inside. We can do the same for the outside. Select one edge and then using control select the other three vertical corners. Select the fillet option, and this will be 0.26. Wall thickness is 0.1 inch. So there it is. Now let's go back to V2, and that's your solid object like so. And this is how you keep building a solid object. Again, we can add another sketch over here to act as 4 corner posts or screws of the PCB. But once again, this is really not the best way of doing proper CAD model. Let me save this file before we go any further. So let's put that under our folders, FreeCAD. Alright, so compared to using the part and the sketcher workbenches, a better way to do this is to use the part design workbench. And before we go any further, let me just delete what we've done because we don't really need it anymore. There. Let me just save this once again. And the part design workbench is a little bit more powerful compared to the combination of part and sketcher. The part design workbench also still depends on the sketcher to make the basic sketches, but the integration between the two is much more better. So let's see how we can achieve the same thing which we did in the previous example using the part design workbench. So the concept with part design is you create bodies, and each body is one specific part of your design. So for example, if we are making an enclosure for our circuit board, which is over here, and we want it to be in two sections, the bottom part and the top part, then we will have to have two bodies in our FreeCAD design, one for the bottom and one for the top. So let's start off by creating a body. And if you look at the model tree, you will have a body available there and also the origin of that body. Let's select body, then go to task, and the next step is to create a sketch. So click on sketch, and it needs to know which plane you want to do it the sketch in. Let's choose the XY plane, which is the top view. Click OK, and that brings us back to sketcher. We can repeat the same procedure as we did earlier quickly. We can make a rectangle like so. Escape. We can give it a horizontal dimension of 2.375 inches, a vertical height of 1.8 inches, and choose these 2 points and the origin. The order is important again. You have to choose the two endpoints first and the center point last, and then choose the equality constraint. But let's say we want to have a more complex sketch to start with. We want to include the fillets over here. Choose the fillet tool, click on one line and click on the other. That creates the fillet, and keep doing this for all of the corners where you want the fillets. That's the third corner, and that's the fourth corner. Press escape to get out of the fillet mode. We want all of these fillets to have the same radius, so choose all 4 of them. Click once, click twice. No need to do control over here. Just keep clicking all the arcs you want to choose. Then use this constrain radius tool to select the same radius for all the 4 arcs that you've selected. So say yes, and we wanted this to be 0.16, sorry. So that's the arc set. We still have 4 degrees of freedom. Again, the width, height, and the center point. Let's first set the width of this. So choose this point and choose this point and make it 2.375 inches wide. Choose this point, and make it 1.8 inches tall. And maybe we can just make the center of these fillet corners equidistant around the center point to fix the location of our sketch. Let's close that. That's what it looks like. And on this sketch we can then add a pad operation, which is in extrude. So click on pad. It asks you for a dimension, so choose 0.25. You can reverse it, you can have it symmetric along the plane, then click OK. And here's where things get better compared to the previous example that we saw. We can now select the top face and create a sketch on it, where we can again draw, instead of a rectangle, let me show you how to draw a polyline. So the polyline tool is over here, and we are going to follow this outline and create a similar rectangle, and then we'll set it with reference to the outside rectangle. So let me go to wireframe mode so it's easier to see what I'm doing. So here's the polyline tool. I click once and I draw a horizontal line like this. Then I want an arc over here. So this is still a line. The next option is a vertical line. Next option is a horizontal line. Then is a outside arc. Then a pie like this. Then an inside arc. And back to straight line. So we want this over here. So choose that. Click once. Secondary click and move to, press M twice to get a vertical line like so. Then press M thrice to get the arc. Scroll again, M twice to get a line. M thrice to get the arc. M twice to get a line. And finally M 3 times to get an arc, but you want it to join up with the starting point, so make sure that when you do it the points turn yellow, at which point they are connected like so. Now we have to give several constraints to this sketch. First of all, each of the arcs needs to be connected to the line through a tangent constraint like so. You can see it here but not over here, so we choose this arc and this line, and here's the tangent constraint. Make sure all the 4 corners have that. Here's the tangent but not over here, so choose these two, make them tangential, click OK. This is a tangent but not this, so choose those two, make them tangent. And finally same here, make them tangent, click OK. Let's select the 4 corner arcs, 1, 2, 3 and 4, and just make them equal to start with. Then we want the center of these arcs to be coincident with the center of the arc of the external rectangle. So we will have to use that as an external reference, and that happens via this toolbar icon over here which says create an edge linked to an external geometry. So let's select that icon and click on the 4 corner arcs of our earlier sketch. This gives us access to the center point of those arcs. So now let me press escape to get out of this mode. Choose these 2 center points and make them coincident using this constraint. These 2 constraint, these 2 constraint, and this might not be necessary. Let's see if this causes it to go over constraint. Yes, the 3 of them are good enough. So with that constraint, we have just 1 degree of freedom left, which is essentially the gap between these 2 rectangles, or what would be the thickness of our enclosure like this. So we can set that by choosing any 2 points like this one for example, and giving it a vertical dimension of 0.1 inch, and close this. Now let me go back because I think I made a mistake in the radius for the arc on the larger rectangle. So let me go back one step to pad, and under pad you'll notice the original sketch that we have drawn, so double click on that. Let's come back here and check. Yes, so this is 0.16. It should have been 0.26 because this is the outside arc. So click OK, close this and close that. And now if we inspect this sketch, you'll notice that this has also adapted to this change because it is related to the earlier sketch that we have made. So now that we have this second sketch ready, let's make a pocket operation in this by going to task and selecting the pocket command. Let's look at the front view so we can see what's happening, like so. And we want it to have a base thickness of 0.1 inch, which means pocket depth needs to be 0.15 inches. You click OK. And this is where we are. Let's go back to flatline view. And if you compare this process with the earlier one, this was much more powerful. It's easier to modify and change it, and the results are the same. So at this point we have done a pretty quick rundown of the Sketcher part and part design workbenches. There is a lot more that needs to be shown, but what I'd like to do is first show you the powerful KiCad StepUp Tools workbench, because that allows integration between KiCad and FreeCAD. Let me just get rid of all of this. Okay, so let's start by getting the KiCad StepUp Tools workbench from this drop down over here. And there's a big, huge range of toolbar icons available. So I'm going to make it easy and just point you to the ones that are really useful. The first thing to do is select the first icon, which is Edit Preferences, which is the same as the Edit Menu Preferences. And go down to the last section on the left, which says KiCad StepUp Tools, and make sure that the main 3D folder location is the same as the one you have selected in KiCad, which is your KSS 3D mod folder location. If you have additional 3D models in some other folders, we can add that as an alternative 3D folder location. Make sure that you check the PCB placement, which should be at a grid origin, because that is what we have set as the center of our PCB in KiCad. So with that done, we can close preferences. Next thing to do is select the second icon that brings up the main KiCad StepUp Tools toolbar. Let me just keep it here on this side. Most of the functions on this toolbar are related to aligning models with footprints, and this is what the initial functionality of this workbench was. And then over time a lot of other functions have been added, which have resulted in a lot of these additional icons over here. It may look intimidating, but it's not all that difficult. So the first thing we're trying to do is import our KiCad PCB over here, then modify its outline to have a more complex shape, then push those changes back to KiCad, and then we have to pull those changes back into FreeCAD once more to complete the whole process. So let's see how that works. You open your KiCad PCB using the third icon over here, which says Load KiCad PCB Board and Parts. Then you go to the folder where you have your project KiCad and select the KiCad PCB. It pulls up the board and populates it with all of the paths that it finds, tells you where the center of the PCB is, and you can click OK. So that's your KiCad PCB with all the parts on it. Now let's look at the top view. What we'd like to do is add fillets on these two corners, and maybe also add a little cutout here in the middle of the board on the left side, so that it's easy for you to insert and extract the coin cells. So we're going to modify this outline. If you look at the project tree on the left, the tiny blinky board, when you expand it, has two groups: board geometries and step models. If you expand step models, you'll find two additional groups if you have parts on both sides, or if you have parts on only one side, then you'll find just one group that says top, and expanding that shows you all of the step models that are placed on the top of the PCB. Here's your battery, here's your electrolytic capacitor, disk capacitor, LED, and so on. And well, like with any FreeCAD object, you can hide it by pressing the space bar. You can move it using the placement properties. So let's collapse that for the moment, because what we're interested in is the board geometries. When you do that, the PCB object you see is the PCB. You can hide that. And just next to it is the sketch, which contains just the outline of the PCB that you have imported. So let's hide the PCB and unhide the sketch, which we would like to now modify. So let's double click this. That brings up Sketcher. And there are a large number of degrees of freedom because none of these have any constraints at the moment. For some of those elements for which we don't want to add constraints and yet reduce this under constraint nature of our sketch, what we can do is select them and use a toolbar icon that says lock, or create a block item that prevents those items from being modified or changed. So we can choose this toolbar icon first, create a block constraint, and then let's select all of these paths on the right side of the board. The two arcs, this horizontal segment, another arc, this vertical segment, another arc, horizontal segment, arc, arc. So these are locked. We can't move them now. Let's escape this function. Let's add a couple of constraints to these remaining three lines. We know these two horizontal lines need to have a horizontal constraint like so, and this vertical line needs to have a vertical constraint. So now we have just 1 degree of freedom, which is most likely the width of the board. So now we can add fillets at the two corners and a little cutout here and modify our outline. Let's use the fillet feature, like over here. Choose these two lines and then repeat it with the other two. Then escape the fillet feature. Select both of these arcs. Select one of these arcs because we want these two arcs to have the same radius as any one of these arcs, and they are all of the same radius. So we have chosen these three arcs, and then we choose the equality constraint. Make sure that these arcs have the same radius as the ones on the other side. And we finally have the width of the board that needs to be set. So let's select this endpoint and this endpoint, and the overall width of our board is set with this horizontal constraint at 2.8 inches. Click OK and bring it here. So we have a constrained sketch, but we still need to add a slot or a cutout over here. So let's just kind of add a wedge kind of a shape. To do that, we can use the polyline feature. Start here, make an angle line, then a vertical line, and another angle line, and something like this would work quite well. Then press escape to end the polyline function. If you don't get this tangent icon over here, make sure that your line is tangential to this by selecting the line and the point and then applying the tangent icon over here. Now, the other thing I need to do is make sure that this line is equidistant along the x-axis. So select the two endpoints of this line and the horizontal x-axis and make that equidistant or symmetrical around the x-axis. Give an angle to this line. So between these two lines, let's make a 45-degree angle. That would make it 135 degrees. And repeat the same angle on the other side. So select the vertical line, select the angle line, choose the angle constraint and apply 135 degrees there as well. Alright, so we have these two constraints set now. Let's set the width of this slot by selecting this vertical line and giving it a vertical constraint of maybe 0.2 inches. Should be probably enough. Maybe we should increase it some more, 0.24. And finally, this gap needs to be set. So let's say we bring it somewhere over here like this and see what this distance is. So I choose the two endpoints of this inclined line and set the horizontal distance as, let's say, 0.12. Alright, so constraint sketch, but we want to get rid of this segment over here. So let's use the trim and edge command. Click here once. It gives us another 2 degrees of freedom, which would be selecting these two vertical lines and making those equal. One, and then choosing any one of them and selecting what its height is, I guess. Yeah, so 0.42 inches. Click OK. and we have a constrained sketch here where we have added fillets on two corners and a notch through which make it easier for us to insert and extract the coins. So let's close this, and this is our revised outline, and this is the original PCB. So we want to change this PCB into this outline. The way you do it, once you have got all of this done in SketchUp, you select this icon which says push sketch to PCB edge. If your toolbar locations are a bit different, you might have to look around for it. Push sketch to PCB. Choose that. Okay. There's a warning. Select one sketch to be pushed to KiCad board. So let's repeat again. I select the sketch. Click on push sketch to PCB. Select which layer it needs to be in on the edge cuts layer, the line width, and click OK. Then select the PCB where this board edge needs to be pushed. Click save and click yes. So that's done. Click OK at this. Let's just kind of save this and do that. Now let's go back to KiCad and see if this has really worked. This is our existing board outline, like so. I'm going to close this. I'm going to close this as well, and then restart PCB new so that it can load the new outline, hopefully, which is here. I can't see it well in this, so let me turn off some of the layers. Fab layers go, courtyards go, and maybe the bottom copper. So here's our new edge, and we can check it out in 3D view. You can see the zone sticking out here, so we'll have to regenerate that. We'll also have to relocate the logo so it doesn't get chopped off, and there might be a ground track going under this notch, so we might have to redraw that. So those are the changes we'll have to do to this board. Let's check that out now. So first off, let me switch off the front silk so I can see things better. And on the bottom silk, I choose the Hackaday text logo. Click on it once, click M to move it, and kind of move it up like so it doesn't get chopped off there. That should be good enough. In which case I'll have to probably move the skull and wrenches slightly below. So choose that, M to move it, and using the down arrow key, move it down like so. So that looks good. Let's just save this. Then let's hide front copper and unhide bottom copper. Hide the fill in the bottom copper pore, and let's check this out. It's likely we should just shift it a little bit so it doesn't interfere with the edge. Let's just do that. Let me select the bottom layer. Let me select the tracks and start from here and do something like that. And then press B once again to regenerate the zone. Looks better now. So now we have that done. Let's just re-enable all the layers: front copper, front silk, courtyards, and fabs. Click home to see all of it. Let's run a DRC to see if there are any errors. Run DRC. Everything looks good. Close this and save it. And now if we go back to FreeCAD, you'll notice that we have the board outline as a sketch, but not the physical board itself, because we need to still pull it from KiCad for the changes to be finally updated over here. So that happens using this fifth icon over here, which says pull sketch from PCB. So in the previous step, what happened was we pushed the sketch from FreeCAD to KiCad, and now what we're trying to do is pull the sketch from KiCad to FreeCAD, the other way around. So let's click on that once, select layer, open in new document. No, I want to replace PCB and sketch in current document, and click OK. Choose the board, click open, and look at the top view. Here we are. Maybe the sketch is still visible, so let me go to board geometries, and here it is. Hide the sketch like so. Cool. So we have made quite a bit of modification to the left edge of the board using FreeCAD, then exported those changes to KiCad, saved it all in KiCad, and then imported those changes back into FreeCAD to update our board over here. So that's how board or edge cuts layer push-pull works in FreeCAD using the KiCad StepUp Tools workbench. Let's look at a similar process that works for the parts that are placed on the board. when you're designing an enclosure for this, it's likely that you will come across certain cases where things are interfering, or you need to move some part slightly away from its existing location, maybe a switch or a connector, so that it aligns properly with whatever design you have in mind for the enclosure. So let's figure out how we can move a part in FreeCAD and then have those changes reflect back in KiCad, and then re-import modifications back into FreeCAD like we did with the edge cuts. Okay, let's select the switch. Let's say we want to move the switch and possibly even rotate it 90 degrees from where it is now. What I can do is right click on the switch and click on transform. At this point I can use the blue sphere to rotate my switch by 90 degrees like so, and I can move it 0.3 inches in the X direction and 0.1 inches in the Y direction. Save this. And maybe I could have done the same with the program header as well, but for the moment let's just take one example to keep things simple so we figure out how it works. So we have this board in which one of the parts position has been changed. We want to push this to KiCad. That happens using the third icon over here that says push 3D moved models to the PCB. For that to happen, you have to make sure that the model that you want to push has been selected. So we have the switch selected and we choose this toolbar icon that says push 3D moved models to PCB. Select the PCB where you want to push it and save it and click yes. It will warn you that the new model position has been pushed to the KiCad board, but there were tracks that it found which were connected to this component. So you need to fix your routing. So we click OK to this. We go back to KiCad. Let's close this and open it again. So we refresh our board. Go to schematic, click on this icon. Let's look at where our switch is. Here it is. So let me hide the bottom copper and silk. Let me also hide the fabricate and courtyard layers here. So here it is, the switch position has changed and some of the tracks are now no longer connected. Sometimes it's easiest to just rip those tracks away. So I'm just going to delete this one track, delete this track, and delete this track as well. Alright, and then make sure I've selected top layer, click on the route tracks, and let's start from here. Move it. This is one track done, that's the other track done. Then let's choose this and do the 5 volt, 2 and 3 like so. We have connected everything properly. Let me unhide all the layers, save it, regenerate the zone, and let's run a DRC. And it says it found a courtyard overlap. This is most likely between our program header and our switch, which is over here. Let's look at the courtyard overlaps and let's hide the fab like so. So a little bit of an overlap. Let me see if we can check this in FreeCAD, because the KiCad StepUp Tools has a collision detect feature. I'm not sure if it will work for this, but we can try. Here it is. This one says check collisions and interferences. We probably need to select two parts for it to do that. So we have switch and we want to check with this one. So we have these two parts selected and let's see if it can detect collisions between the two. Nothing. You click on it, nothing happens. Let's see if we can move it some more and cause it to have a collision. Let's translate this switch some more. Maybe another 0.1 inch. Well, this should obviously show up as an error for sure. Select the switch, select the header and look for collisions, and this is the overlap between these two parts that it has found. So that's how you look for collisions in KiCad StepUp Tools. Let me do a Control Z and undo that. Yeah. Alright, so let's go back to KiCad. And this looks good, but since we've come this far, we probably can just move this switch a little bit away so we can pass a DRC from here. So I'm going to move it just a little bit like so. Place it here, enable the front copper, get rid of these tracks. like so. Then select track routing on the top layer, and that's one, that's another, and one last one. And if we wanted to, we could even have rotated this program header a bit, but maybe I can leave it as an exercise for you folks to do it and try it out yourself to see how it works. Okay, so let's regenerate our copper zone once again. Press B. Let's zoom out, enable the layers, and run a DRC before we proceed. So that's done. That's my first layer. Click on DRC. So that's cleared our error in the DRC and things look good. Let's make sure we save it. And now we can go back to FreeCAD. So first, let's make sure that we pull the most current footprint locations from KiCad back into FreeCAD. So let's select the switch and pull 3D model position of the switch from FreeCAD back into KiCad. Select the board, click open, and click OK. So this is the fresh location of the switch is pulled from KiCad into FreeCAD. Now, as a final step, what we need to do is make sure that these drill holes, they are also refreshed. We are going to wrap it up by selecting the pull sketch from PCB edge option. Make sure you choose the replace PCB and sketch in current document and click OK. Choose the board, click open, and let's make sure we hide the sketch. Let's look at the top view, and here we are. So that's how you push and pull footprint positions from FreeCAD into KiCad and back the other way around. So we've done two things here. We've modified the edge and we've changed the position of one of the footprints, and we have made sure the changes are updated in both FreeCAD as well as KiCad. Let's look at another feature of the KiCad StepUp Tools Workbench, which is very useful, and that is to align 3D models with KiCad footprints. This can be pretty useful because quite often when you download models, they may not be aligned with the footprint that you have. So let me start off by creating a new document, and we are going to work on the battery retainer clip that we downloaded from Keystone last time. First off, I'll have to manipulate these step files. I'm going to do a file import and get the model that we have downloaded from Keystone. Now, if you'll notice, these are two separate parts, but in the model tree they appear as a single part, which means that they have been fused during import, and that is not what we want. If this is what you see, then the way to fix it is go to Preferences under Edit, go to the Import Export section, go to the Step tab, and if you have Enable Step Compound Merge checkmarked, then remove the checkmark, click Apply, OK. And now let's delete this and do the import once again. And this time, if you look at the model tree, you'll notice that we have two individual separate parts imported over here. Next, we need to figure out how to align both of these so that they line up with each other. Now, one easy way of doing that is to call up the manipulator workbench, and this is a nice handy caliper which is useful for making measurements. So let's choose that, and what we'd like to know is the distance between the bottom of the metal clip and the bottom of the plastic insulator, and then offset one of the two objects. So let's click on the measure button once, zoom in so you can grab a corner of this metal retainer clip like so, then scroll until you can grab this corner point, and if you look at the values now, we can see that in the y direction, the offset is, let's round it off to 15 mm. So we have this measurement available. Let's close the measure tool. We can delete the distance labels now. Let's zoom all. And the plastic insulator, go to its position tab, and in the y-axis this needs to be translated by a distance of 15 millimeters. Now we are using imperial units here, but in FreeCAD you can actually enter even metric units while you are doing imperial drawings. So this is nicely aligned now. That solves a part of our problem. Next, let's enable the toggle axis crosses and just inspect our model, and we can see that along the x-axis it is not centered, and it doesn't look centered along the y-axis, not along z as well. So it's kind of offset in all of the three directions. So let's create a reference object, and we can move the battery retainer with reference to that object. Let's see if that works. So let's go to the sketcher, create a sketch in the XZ plane, but it needs to be reversed because I see the rear face over here. So reverse direction and click OK. Zoom in a bit, and all I want is some reference object, so I can place even a rectangle like so over here. Click escape, make both of its sides equal, and then give it a dimension. Although all of this is really unnecessary, all we need is this corner point over here. But let's say that it's whatever this value is, and close it. So we now have this reference sketch. Now before we proceed further, let's perform another action on our battery retainer, which is to grab these two objects, the metal clip and the plastic insulator, and merge them again, because now we have them moved and aligned with each other. So we can go to the part workbench, and after having selected both of them, choose the union option. That gives me this fusion object, which is a single object that is easier for us to manipulate now. Let's reorient this object so that the top is facing where the top surface should be, and the front is where the front should be, and it's not aligned in those axes. So let's go to transform. Let's rotate around the z-axis like so. Also rotate along the x-axis by so, and then click OK. Let's now see if we can move the fusion object and have it align up with the origin. So let's see if we can get the y-axis offset worked out. Let me go to wireframe mode and then select the caliper tool. Click on caliper once. Choose this corner of the square that we've created. Click on an arc so we get the center, and let's go back to top and check it out. So in the y direction, the offset is 1.027 mm. So let's close measure tools and see if we can move this by 1.027 in the y axis. 1.027 mm, and click OK. So we can now remove these two labels, and just to verify, let's go back to manipulator, click on caliper, click on caliper. We can select this endpoint and this circle, and we can see that dy is now a pretty small number raised to -0.5. So maybe that's a rounding off error. So we can close measure again, get rid of these labels. So we have things aligned along the y-axis. Let's see if we can get the same thing done along the x-axis. Let's go back to manipulator. Let's go back to the caliper, and let's click on measure, click on the origin vertex, and then select this arc, and in the X direction this offset is now 1.318 mm. So let's do that offset, 1.318. Close this. Fusion X is minus 1.318 millimeters, like so. Now let's get rid of the earlier label and I had the wrong direction. It should have been a positive 1.0318 instead of negative, so that is fixed. Looks pretty much centered now in the X direction. So here's the isometric view, and now let's see if we can fix things in the Z direction. So once again, go to manipulator, click on the vernier, click on the vernier, click on the origin vertex and one of these lower end vertices. This one should be good enough. And in the Z direction, this is 11.414 millimeters. So let's get that fixed. Fusion 11.414 millimeters, like so. Click OK. Let's get rid of these distance labels. Let's hide the sketch that we have created. Let's go back to flat lines view, and here's our battery retainer clip with the metal and the plastic insulator parts aligned with each other, and then the whole body pretty much aligned along X, Y, Z 0. So at this point I can take this Fusion object and export it as a step file. I can use the same name and append it with aligned. So, and save that. So that's saved, and at this point we are done with this object, so we can close the file without really having to save it. Now let's again open up a new document. So the next task is to import the footprint from KiCad PCB and align this model with the footprint. So let's go back to KiCad StepUp Tools. Let's enable the primary toolbar. So let's start off by importing the footprint. For that, choose the first icon over here which says Load KiCad Footprint. Go to your project folder under KiCad, under Tiny Blinky. You should have a .pretty folder, and within that folder you should have your modified battery footprint, which is a 3024-2. So open that. So that comes up over here. So let's import the step model that we have created. Use the second icon here which says Import Step Model. Navigate to the project folder. I think under FreeCAD we have saved the aligned step model, which is the one we just created a couple of minutes ago. Open that. So here's our step model and here's our footprint. It needs to be rotated 180 degrees along the Z axis. So that is pretty easy. You have these three rotation options over here. Rotate along X, Y, and Z. And you can choose the angle over here. We'll have to select the object first, which is this one. Then rotate twice along the Z axis. Let's look at the top view and make sure that it is centered along the X axis by using this icon, Center X. So that fixes the centering on the X axis. And I think center on Y might not work because the outline of the existing footprint doesn't really match the actual model that we have. So we can still try it. There, it doesn't line up. So we'll have to align this manually by using the translation in the Y axis, which is this icon over here. Now we'll have to probably do negative translation. So negative 0.1. And keep doing this. Let's zoom in to verify if it is aligned. Maybe one more step. Yes, so that looks good enough. So now I can export it. So let me choose this fusion. First of all, let me rename it by clicking on it and doing an F2, and let's give it a name. Keystone underscore 3024-2. So we select that, and then we use this option here which says export to KiCad, and it will export, as I mentioned earlier, in two different versions, the step version and the VRML version. So click here. It wants you to save, but I don't need to save this. Mesh deviation can be left as it is. Click OK. Crease angle, click OK. And here you can set fresh color. So here's the original, which is the chrome color, and the new one can be set as something else if you'd like to. And for now, let's just click OK, because that color is what we require. And same thing with the color for the plastic insulator. You can set a new color if you want to. Click OK, and it has exported and saved these two files in this particular folder. Let's open it up. Here, these two. So I can now grab these two and transfer them to my project folder. So I like to put these kind of models in within my KiCad directory itself by creating a new folder here, which I like to call packages 3D, and paste my 3D models over here. So all local models that I need, I push them in a folder like so within KiCad. So with that done, we can now return back to our KiCad project, and let's check it out first in 3D view. This is what the existing footprint looks like. And also, if you look at the settings in 3D, we had to apply several rotation and offset values over here to make it line up with our footprint. So let me delete this footprint, and now using this icon I can ask it to use the footprint from my KiCad project folder under Tiny Blinky, under packages, the WRL model like so. Click OK. So there it is, nicely lined up. No need to make any adjustments over here. Click OK. Let's save this, view this in 3D viewer, and there you have it. We have finally managed to get a much more realistic model of our 2-coin battery retainer with a plastic insulator. So let me close this and go back to FreeCAD, click OK here, and I can now close this without saving it. Here's my Tiny Blinky project in FreeCAD. Since what we have done in KiCad is just changed the 3D model but not its position or the footprint, it makes sense to kind of just delete this whole KiCad PCB file and re-import it all over again. Choosing this and reloading all of the parts. Put this in a new tab so we can close the earlier one without saving it, and let's save this as our original file. Here's the top view. So this completes the whole process of taking a step model, making any adjustments that may be needed on it in terms of position, rotation, translation, and so on, and then opening up the KiCad PCB footprint, importing the step model, aligning both of them together, and exporting it all back again as a pair of models, one in step format, one in VRML format, and then apply those changes in KiCad and refresh those changes in FreeCAD by re-importing the whole file all over again. So that is about all that we can cover today in this session. There is a lot more that we haven't been able to cover, some of them pretty interesting. For example, using KiCad StepUp Tools in FreeCAD, you can create a KiCad footprint from a step model. The other thing we haven't looked at is how to actually build a complete enclosure. I have just got you started by introducing you to the Sketcher workbench, the part workbench, and the part design workbench. What I will do though is that on my GitHub repository, I will, besides of course posting all of these files that we have been using for the 4 sessions up until now, I will create an additional folder where I will add my reference files. I have also not covered another important function, which is to use what are known as shape binder objects. And let me try and see if I can very quickly show you the concept. Here's a circuit board, and let's say we're trying to now build an enclosure for this. So we go to part design, and under task we select on creating a body, and now within this body I want to use this PCB as a reference object for building your enclosure. So while our body is selected, we can click on the shape binder tool over here. It says create new shape binder tool. Click on that once, select object, click on the PCB and click OK. What FreeCAD does is it creates a linked object that is a replica of the Tiny Blinky PCB. So I can hide Tiny Blinky, the whole object, and this is the shape binder. I can now use all of these edges as a reference for creating my enclosure. So with that, I think we can call it a wrap to this session 4 and this whole series of classes of Introduction to KiCad and FreeCAD at HackadayU. I will see you on Friday during the office hours, and if you have any questions or doubts, please post them on the Hackaday project page or post in the team chat, and I'll try and answer to the best I can. Thank you for joining me for this 4-session class of Introduction to KiCad and FreeCAD at HackadayU.